Namaskar and good afternoon to all attending this 35th national webinar organized by NATMO from Department of Science and Technology, Government of India. I would like to request all the participants to kindly mute your system. This is very important. Today, we have assembled here to celebrate National Youth Day. In 1985, Government of India declared Swami Vivekananda's birthday, January 12th, as National Youth Day in honor of the great philosopher and monk. Born on 12th January 1863, Swami Vivekananda played a crucial role in changing the way people perceived India worldwide. Swamiji aspired to lead the vision of youth and transform them into reality. This year, the theme for National Youth Day is It's All in the Mind, which essentially filled motivation in youth to progress in a healthy way. Today, we have a young scientist with us, Sri SOMNATH MAHATO, who will share his field of work with us. He will speak on the topic GNSS, Navic, compact modules for geolocation and applications. But now, I would like to request Director NATMO, Dr. Tpp Banerjee, to deliver a welcome address for our guests in this webinar. Madam, please.
Thank you, Madhurima. I welcome you all who are present over here in this virtual platform in this special day, which is the 35th event of our webinar series. And this is the special day, National Youth Day, to commemorate the birth anniversary, 159th birth anniversary of Swami Vivekananda. And like every year, we used to call the young professional for this day to deliver their lecture, special lecture from the young professional. So I first welcome all of you in this web platform to listen from a young professional, talented professional, of course, Mr. SOMNATH MAHATO, who have already pursued his MTech from Bardwan University, and he is now pursuing his PhD in NIT Sikkim. And Mr. SOMNATH, I know him very well from the last 3-4 years because he is most talented in regards to his technology development, and he has been awarded with several scholarship, fellowship, and awards from different national and internationally reputed organizations. And the most the important part is that he is not only talented, he is the most humble and polite in his nature. And today we will listen from him. Especially, I am really inspired by his deliberation in different forum on the development of low-cost technological application on geolocation using the GNSS and Navic compact modules. I hope he is now in DRDO for some award or function. He is there. So today, without any further discussion, I request Madhurima to welcome SOMNATH for his deliberation. With this, I thank you all.
Thank you so much, ma'am. And now we will hear from today's guest, a young scientist, Sri SOMNATH MAHATO, who is a technocrat from the field of electronics and communication engineering. After doing BTech and MTech, he is now pursuing PhD degree from NIT Sikkim. He has worked at ISRO project as Junior Research Fellow at IIT Dhanbad. He was awarded at a national and international level, as well as received scholarship from UK and Japan. He has published more than 45 research articles in national and international journals and conferences, book chapters. Today, he will speak on GNSS Navic compact modules for geolocation and applications. I think it will show new path for GIS platform users like NATMO. And it's your time, Mr. Mahato.
Thank you, madam. Am I audible, madam?
Yeah, you are audible.
Yeah, thank you, madam. First, I would like to acknowledge my sincere thanks to Director NATMO, madam, and the entire team of NATMO to select me to talk in this platform on which day Swami Vivekananda have birthed. So it's my honor and privilege to share my knowledge uh, with all of you. Is my screen is visible?
Yeah, it's visible. Please carry on.
Thank you, madam. So today I will talk on GNSS Navic compact module for geolocation and its application. So whatever I not say I have done or in our lab, GNSS laboratory Badawan, and we call it as a GLB. We have developed and what we have done with this low cost compact receiver, I'm trying to present those things and those are very accurate and those receiver are very compatible with our survey grade or different other monitoring purpose previously what we are used. So we think we are move forward with these compact modules, and so I will today I will talk on GNSS Navic compact module for GNSS and in application. So as Swami Vivekananda's today is the birthday, and this left side, this Swamiji statue is in our university. And here I have mentioned Swamiji's one quotation. If I can get some unmarried student, I may try to send them over Japan and make arrangement for their technical education there, so that when they when they come back, they may be return their knowledge to best account for India. That's what a good thing that would be. So why I take this quotation, later you may be fine. I take the quotation from the below link sources. So these are my content. I will talk on what is the available GNSS receivers. Those can be used for special purpose or geodetic application. Later, I will talk on compact modules and compact GNSS receivers. So, after that, I will talk this compact receiver. You can use it for single point positioning, precise point positioning, for real-time kinematic, and for atmospheric monitoring also with this small compact receiver. Then I will show you some different kind of application what our lab and we have developed those kind of application and try to do those kind of work. And next I will talk on Navic and their advantages. Navic, as all of you know, it's our own indigenous navigation system. What are the advantages we would get? I will talk to you. Then what our lab have provided, the GNSS training with this compact module, we will tell those things. And all of you may aware that for geolocation, you need minimum for analytical, you need minimum 3 numbers of satellites. That is for X, Y, Z. If you have, and for another, you need for timing. So you need 4 number of satellites. If you have the 4 number of satellites, that means you may get your location from GNSS satellite. I will not go into the technical details because you know those things. So with this, so from that GNSS, what we will get highly precise location accuracy. The highly precise means we will get up to millimeter level accuracy. And there with this GNSS data, we can get the velocity information. If you are in a car or in a moving platform, high dynamic platform, you will get the velocity information from this GNSS receiver. You will get the timing information, and so many applications are there. So I will tell you a little bit. So see from this slide, yeah, I have logged that this how many satellites are available on 11 January 2021. That means the yesterday. See, GPS 32 satellites in the sky, 28 satellites are active. For GLONASS, 22 satellites are active. For Galileo, again 22 satellites are active. BEDO, 44 satellites are active out of 49. See, these the GPS, GLONASS, Galileo, and BEDO. These 4 are the global system. Anywhere of the globe, you can get your position location using this constellation. So, if you are in between country like Japan and India, you will get their own satellite system, and those satellites have they are not globally available. Their regional services are available currently. So QZSS 5 out of 5 is active. As you know that in India, navigation with Indian constellation, it's our own navigation satellite system. Out of 7, currently 6 satellites are active. And the fewer S-bus available. Indian S-bus system is Gagan, and US S-bus system is WAS, and like that way. BDS, BEDO, that the system is BDS S-bus. Gnss is for Europe S-bus system, and SDCM for GLONASS S-bus systems. And that QZSS S-bus system is MSAS system. And you see the next how different types of, see, so many satellites are available. As earlier slide, if you count or if you add those numbers, you may get more than 100 number of satellites are available above the sky. So, Asia-Oceanic region, this region is the best location where geographically you would get maximum number of satellites. See, multi-GNSS Asia, they have done a simulation. They said this number of maximum satellite you would get. So then we think we would get in our laboratory, that eastern part of India. Our laboratory is, as you know, that the University of Burdwan. 4th May 2019, we have chosen GPS, GLONASS, Galileo, BEDO, Navic, and QZSS satellites. From there, we at that time at 1500 hours, we'll get 54 number of satellites are available in eastern part of the India. And similarly, we are trying to log data from Western India, that we have logged the data from SBNIT Surat. From there also we have take the data GPS, GLONASS, Galileo, BEDO, Navic, and QZSS. there we have found that the 54 number of satellites are available, but 45 number you can use. And we have logged the data, you have 23rd January 2019 at 1800 hours. And currently, you may know that currently everybody are using the Android smartphones. So Android smartphone have a GNSS sensor. With that GNSS sensor, few apps are already available. If you logged with that apps, you can get lots of satellites in India. How many satellites are available above your sky, above the sky? So we have logged it, and we want to check how many satellites there. We have found that a lot of satellites are available. So with this slide, we can conclude that Asia Oceanic region is the multi-GNSS signal hotspot. Why we say this term multi-GNSS? Means more than one GNSS system. So GNSS, why multi-GNSS is required? Suppose if you are in a forest environment, or you are in a subway, or in a tunnel, or in a canopy environment, there you need at least 4 number of satellites. That time that GLONASS may not support, or GPS may not provide the 4 number of satellites. So if we together we can take GPS plus GLONASS, or we add Galileo, or we add BEDO, then we may get or we should get 4 number of satellite. So that's the one more advantages for multi-GNSS signal. And we are lived in a area where we can get maximum number of satellites. I have shown to all of you. See, now right now you know that how many satellites you get. So right now you must know how many receivers are available, and which purpose you can work with those kind of receiver. See, if you want to do for geodetic or survey purpose, then this kind of receivers are already available. But these receivers are very much costly, 20 to 30,000 US dollar. And those receivers are very bulky. If you are doing for single point positioning data, or you are doing in that DGPS or DGNSS or Rtk, you see from this picture, you can see this all receivers are so many bulky. It's the height is too much, and you need an external power supply, and you have to put the antenna and all those things. The antenna weight is very high. So if you put a geodetic survey grade antenna, that the antenna weight is more than 10 kg. And for special purpose, some receivers are also available. This receiver is for timing receiver, and this receiver is, if you are interested doing some work for atmospheric correction, GNSS ionospheric scintillation, or take monitoring, this kind of receivers are already available in the market. And if you are looking for the simulator, you want to do your simulation and take the data and record it. You want to save all the scenario inside GNSS scenario inside your receiver. Like this is a ResLogic receiver. This receiver can log overall whole the scenario, and later you can record it later. You play those data with this system, and see all those this kind of receivers, they are a multi-constellation. That means multi-GNSS. You would get the multi-frequency. That means the each constellation, like GPS, has the L1, L2, and L5 signals. So that means it's a multi-frequency signal. And the data output. So what's the data output you will get the outside? You will get the NMEA data, you will get the RENAX data, and you will get this receiver. Each and every receiver have their own proprietary data. That proprietary data you will get. But that proprietary data, you can convert it in a RENAX format. If you require, you may convert it this. So now I have discussed that this till now I have discussed survey grade GNSS receivers. So last few years, you see these compact GNSS receivers are available in the market. So I have put some receivers here. And see, these receivers are single frequency and dual frequency. Single frequency means it can track or it can log only one signal from one constellation, or maybe two it may be dual frequency. Suppose this Alistair, it's dual frequency for Galileo, but single frequency for GPS, GLONASS, BEDO, and for Navic. So we categorized it as a single frequency GNSS receiver. And see, this kind of single frequency GNSS receivers are available. This is a non-exhaustive list. What I have shown it here. And right now, what I have found only these three. Dual frequency GNSS receivers are available. This is u-blox F9P. They are the dual frequency version, this company. This NTLab 104 and 106. This receiver can give it to you Navic dual frequency data L5 plus S, GPS dual frequency data, GLONASS dual frequency data. And Mosaic it's also a dual frequency, but it from this Mosaic and u-blox F9P, from these two receiver, you will get only Navic single frequency data. That means L5 band data. These two receiver cannot provide Navic S band data. That is not a compatible for that. If any more is there, I have to check, and I will definitely add on it. So right now I have discussed all these this kind of module. So why we use this kind of module? So as we are Indians, so with our what's the mindset when we go for any shop to buy anything? कितना देता है, कितने में मिलेगा? So that means, so what's our mindset is how the minimum cost will get the maximum benefit. That is the typical Indian nature. So for the price will be USD $100 to USD $500 for this small GNSS single and dual frequency receivers. And the antenna, you see here few types of antenna there. Their cost is $5 to $50. So from this snapshot, you can you can easily understand these are small size. It will take low power consumption. Low power means it take 5 volt DC power supply. if you have a computer or desktop or laptop, through that USB, it can run properly. And this kind of receiver also provide NMEA data and the Renax data, and as well as they will give it to you the proprietary data also. And as these receiver are very low cost, so you can do for Arduino type of application. For these two receivers are compatible with Arduino. And Rtk, you want to do real-time kinematic, then you can do this. All receivers are Rtk enabled. So Rtk, when I came that slide, I will detail talk on Rtk. So and these all receivers are capable for carrier phase based measurement. If you want to do Rtk, then you need a carrier phase based measurement. So right now I have told you that you need a 4 number of satellite to get the data. So if you have that means, suppose you have 4 GPS or GNSS satellites are available above the sky, okay, and you are here in the earth. So what is the distance between your location and the satellite? The distance will be approximately 20,000 kilometers. And what's the error you will get? See, you have to get the main error is the ionospheric delay. See, you have to come with this, all the ionospheric region. So you may get tropospheric scintillation and tropospheric ionospheric scintillation, tropospheric delay, ionospheric delay. So instead of you receive this straight data, you will get a zigzag data. So that is the pseudo-range data. So for that, and where you put your receiver, you have to be focused on it. You have to put your receiver in an open sky environment. So otherwise, if you put anywhere and there are big tree and big houses are there, you may get the multipath. And I have forgot to tell you that the GNSS receiver have also that has also few errors. The errors are satellite ephemeris error, satellite clock error, satellite geometry error. Okay, so there are few techniques are also available to mitigate this error, and you will get your data your data with the accuracy of millimeter level, up to millimeter level if you require. And here I will suggest those who are new in this domain, you can read this book, Introduction to GNSS. This book is written by Novotel. This book is for the beginner. So I will, what I think, if you read one at a time, you will get a clear view about the GNSS system. Suppose here one data set, I have shown it you, the left side, you see when we have logged the data at that time, this scattered data you will get, because you cannot get your one single solution point with this kind of error. The error are mainly for the atmospheric and ionospheric data. So I will not talk on much on this. So there are the few techniques are also available. If you are happy with meter level accuracy, then okay. Then your SPS signal is good enough. I will come forward for SPS. So single point positioning. Yes, from this, as I already mentioned, the few techniques are already available. That is the single point positioning SPS. And relative positionings are also available. That is your differential or DGNSS or DGPS. Okay, for that you anywhere you log the data for relativistic positioning, you need a base and you need a rover. For that, you need at least 4 number of common satellite. Okay. For relativistic positioning, one thing also I have to tell that Rtk, real-time kinematic. Okay. You will get for base and rover, see from this figure, middle figure, you have to be you see the 4 common satellites you need. So from the base, you will get the signal and the same satellite must send the signal to the rover. Okay. And when you are doing for PPP, see, you have to log the data, 24-hour RENAX data, and you, as per your requirement, you have to do what is your requirement. So from this slide, we can conclude level of accuracy level is required, system complexity, solution availability, reliability, and it's very importantly the cost. How much cost you can bear. And all these 4, that means single point positioning, DGPS or DGNSS, Rtk, and precise point positioning, you can do with this small kind of small receiver. So now I will move forward with single point positioning. So we want to check how these receivers perform. So what we have done, we have take an experiment. We have done an experiment. So these are we have considered this like a AR25 antenna. I have already mentioned this surrogate receiver antenna are heavy. Their weight, you see, this is too much bulky, and this weight approximately 10 kgs. And here we have another Java Grand G5 antenna, and we have taken U-Block's commercial patch antenna, and we have collected the RF data, and we have split it in a 1:4 active GNSS splitter. Why we split? At the same time, we have logged Java's TrampLS data, that is the survey grade data, survey grade receiver. Okay, survey grade dual frequency receiver. We have logged Alistair data. As I have already mentioned, this Alistair is single frequency. This module is dual frequency only for the Galileo. And U-Block's JDD F9P, I have already mentioned, this receiver is dual frequency capable compact module, and U-Block's MAT. And we have logged simultaneously the data in our desktop, and we have published it. If you are more interested, you can go through this paper, you will get. So next I will show one of the result. Okay, see, using survey grade antenna, as I mentioned that earlier, so if you get data means you get latitude, longitude, and altitude. So each and every thing has your one error. That means north error, up error, and east error. So we want to check the error, as I had mentioned that we have logged the 24-hour data. Okay, so here also we have logged 24-hour continuous data. Okay, and you see this survey grade receiver Java's Trampele for the north arrow, it will imply the same as uBlock's F9P data. So you see from this north arrow, east arrow, and up arrow, these survey grade receiver, Java's Trampele receiver are nearly matching all the error compatibly with uBlock's F9P. So from this, you can easily understand that your what is the cost difference. See, I have already mentioned this kind of survey grade receiver cost is more than 10 to 15,000. Okay, and this uBlock's F9P, what is the cost? uBlock's F9P receiver cost is approximately below $300. Okay, so with the cost cutting, you will get the similar kind of performance and similar kind of accuracy. See, and using this survey grade antenna, and we want to check with that small commercial patch antenna and doing the same experiment as earlier I have mentioned. You have seen the block diagram, and you see that Java's Trampele's data is lying with uBlock's F9P dual frequency data. Okay, for north error, east error, and up error. Okay, so from this single point positioning, what we can conclude here, we can conclude this low cost receiver are compatibly with your survey grade receiver. Okay, different types of antenna we have checked as earlier I have mentioned, and so you will get the accuracy level of below 5 meters with this, as what the survey grade receiver provide you the accuracy that is the below 5 meter, and this small dual frequency receiver also provide you the below 5 meter level of accuracy. So if you are happy with this meter level accuracy, then for you this SPS technique is enough. Okay, so now I can forward with TPP technique. So earlier I have mentioned from the PPP, that means precise point positioning, you will get a millimeter level accuracy. So for that, you need a dual frequency receiver. What we have done, this is our antenna, and we call it as a antenna farm. Above our GNSS laboratory Badwan or GLB, we have these so many varieties of antenna are there. You may get this antenna. This is a Leica antenna, the too bulky antenna. So another antenna we have considered for this experiment, that Java Grand G3D, this antenna, we put it here. Okay. So this with this we have another Java Delta geodetic receiver. We have logged it 24-hour data with this our PC, and 24-hour RENAX data we have logged. And then we have converted the RENAX data and using Rtk. Rtk is a open source, I would say, software. Okay, when I will talk with Rtk, then I will more discuss on Rtk, and we will convert here RENAX 2.11. This is the format we have converted, and the few agencies are already available where you can upload your data and you will get the PPP result. Okay, this is the most simple and cheapest way. Or if you want to do the post processing, there are several agencies softwares are available to the PPP and it can mitigate all those things, but the cost is very high. So if you don't have that much of money, so you log the data and just uploaded it. For there you have to write your email address. If you type it, you will get a certificate. They will provide with the confidence level of 95% accuracy. They will give it to you a millimeter level accuracy data, and you will get the PPP. And we will try to do the same thing for, as I earlier mentioned, we have that uBlocks F9P receiver and NTLab 104 receiver. We have logged 24-hour data with 1 Hz GPS data, and here also we have logged 1 Hz GPS data. And right now, for if you are doing the PPP correction, you have to log this NRCan, OSPOS, OPUS, and this kind of online services are available. So you have to log the GPS, or either you have to log GLONASS, or you can combine GPS plus GLONASS. These three, if you take the data combination, and you log the data and convert the RENAX file using Rtk lib, and if you upload the observation file to this OSPOS, OSPOS is an Australian agency. If you uploaded it, they will provide you that with the accuracy of 95%. They will provide you PPP result. Similarly, if you for this, you have to upload only GPS data. GLONASS data here not available. If you upload it, they will give you a simple error message. And if you uploaded it here, you will get GPS data, GLONASS data, and GPS plus GLONASS data. And you may get the accuracy of millimeter level. If you have logged the data very correctly and do the experiment, you did your experiment in a survey good way, then you will definitely get millimeter level accuracy. Otherwise, you have to check why your accuracy level is degraded. So here I have Cursi to NTLab. NTLab is a Lithuania based company. They have sent us to various kind of these receivers. Okay, Navic L5 plus S to our lab for testing and the research purpose, research and educational purpose. The cost of free of cost. So here I have to acknowledge NTLab for the hardware support. So now, as earlier I have mentioned the accuracy of millimeter level. See what I have told you. You can see here. You get the GPS GLONASS GPS plus Galileo data. Here you see the error level. Error level is your millimeter level. You will get the best. What I can suggest, if your receiver is dual frequency compatible GPS plus GLONASS, you may log the GPS plus GLONASS data and uploaded it. So you will get the better accuracy. This simultaneously we have logged for in a week. We have logged simultaneously, and we want to check about the accuracy. Okay, and similarly experiment during the lockdown we have done with this uBlocks JDD F9P NTLab, and here also we will get with more or less compatible. I would not say the same. I will suggest it's a comparable data. If you take the GPS plus GLONASS, you will see the millimeter level of accuracy. If you are more interested, you can visit this paper. You will get lots of information. From this PPP, what we can conclude? We can conclude the visibility of commercial compact dual frequency GNSS module can be studied for PPP solution. Okay, and this kind of receivers are, with this kind of receiver, you may get the millimeter level accuracy. Okay, and you see those results are very much comparable. Okay, and if you take GPS plus GLONASS or GPS data, you see there the altitude. The altitude value. Right now, I have only talked with the latitude, longitude. If you go for the altitude, this ellipsoidal height, you see there, you may get the below 20 centimeter accuracy for the vertical coordinate. Okay. So from this, if you need a millimeter level accuracy 2D and you need a centimeter level accuracy in vertical coordinate, so you may use with this technique, you get, okay, with this kind of small receiver. So what is the advantages? The advantages is cost, size, power requirement, what I have already mentioned, and this receiver can compatible with the PPP, okay, precise point positioning. So now, earlier I have already mentioned about the Rtk leap. So Rtk, what does it mean? It means real-time kinematic. So instant, okay. So for that, what earlier I have mentioned that if you take the data for 24 hours, you have logged and you have processed, and you have processed means observation and navigation. You have to convert it that the Linux data, and you have to upload it the observation data a few agencies. Then you will get the millimeter level accuracy. For that, you have to wait for 15 days for the final product. The final product means you will get the IGS station data, International GNSS Service data. They will give it to you, the whole the accuracy after 15 days. So if you are, no, I cannot wait for the 15 days. Instant, I need a decimeter level accuracy. So here the technique is that the real-time kinematic using Rtk. Why I choose that quotation Japan? See, you see this is a Tomoji Takasu sir. He's the developer of Rtk. I get a chance to meet him and attend this professor class during GNSS workshop 2019. So he take 15 years to develop this Rtk software, and what he done after completed it is just open source that. Okay, if you are interested, you can download it from there. So what Swami Vivekananda very early says, he want to send you why Japan, because those people are ready to help you. Okay, they are not, okay, I have developed those things, we'll keep in our community for our country. He made think like, then we cannot get so much easily. This we have to purchase. Various Rtk softwares are available in the market, but the cost is too high. But if you this Rtk software is very much powerful. He spent to develop it for 15 years. Okay, from this software you will log the single frequency data, single frequency positioning. From this software, you can do the DGPS or DGNSS, or you can do the PPP as earlier what I have done. And next we will do for the Rtk experiment. For the Rtk experiment, as earlier I have mentioned, for if you want to do for the DGPS or DGNSS, then you have to do a code-based measurement. For the carrier phase-based measurement, you have to do the Rtk and the PPP. PPP and Rtk, you have to do the carrier phase-based measurement. Okay. So with this small module, compact receiver, U-blocks and SkyTrack module, with this you can do your Rtk, and instant you will get centimeter level, or somehow you may get the millimeter level accuracy with a few techniques. And we will get with this software, if you are anybody is used Linux compatible, this receiver also, the Linux compatible versions are available. So with this, what we have done, we want to do, we have done a few experiment. So this is the base station. As you right now understand, this is the survey grade base station, survey grade antenna, survey grade receiver. We have logged it in a computer. This is my base station part. And what we have done at the rover end, we have put a survey grade antenna, and then we have split the signal with two receiver. This is the Java's Trampelus, another survey grade receiver, and another signal is there, U-blocks M8T. We have split this RF signal, and simultaneously we have logged the data. What data? We have logged the Rtk data. Through Rtk data, you need an internet connection, through where you have to get the correction data. So you have sent the correction data through IP. You can send the RTCM3 message signal. Okay. And we have done this kind of experiment, and see the right side, you see, we have also done we have removed this receiver with the low cost receiver. Okay, both sides we have put the two rover, we have put two small modules, single frequency small module, and here we want to check. This is my another single frequency base, and this base and this rover. Okay, single frequency base and single frequency rover. What we will get the data, and we will take the data for this survey grade receiver, dual frequency, and here one single frequency receiver. We have put it and rover side, and we want to check it. The base length distance of 20 meter, we will get 2D values, 2D accuracy. You see the 26.78 centimeter for survey grade receiver for this, okay, and 27.76 for this. And when we consider this as a base and this as a rover, we will get the decimeter level accuracy instant. Okay, so we have done several kind of experiment. We have get centimeter level accuracy. For that, you have to log. With my experience, you have to log at least 15 minutes data to converge your data. Okay, you want to take instant data or instant what you get the position solution. You will get the decimeter level accuracy. Okay, For the convergence time, it's required up to 15 minutes. So my suggestion is, if you are doing Rtk, then you at least you have to log the 15 minutes data. Okay, if you are interested with this two kind of experiment, what we have done, put the references also. With this, we want to extend our work. Okay, we want to extend our work to various distance. See, at the distance of 220 kilometer, right? Say GPS, you would get the below 2D accuracy, below meter level. You see the beauty of multi-GNSS. You see here, you will get 31 centimeter, okay, 2D, and the 3D, what you will get 19 centimeter, okay, instant. Okay, that means you will get your location position accuracy is below 5 meter, okay, using this small module with this Rtk technique, with the help of Rtk lib. Okay, for that you need a static IP. Okay, and you have to send this RTCM message through data to a server, and those server you have to receive it. And again, we have extend this up to 228 kilometers. That means base rover distance, what we have done is 228 kilometers. And see what we will get. We will get up to 40 centimeter accuracy. Okay. And there 3D we will get 20 centimeter accuracy. For this work, I will like to acknowledge ITR DRDO for the CARS project. Right now I am doing this project, associated with this project. So till now I have completed with the single point positioning, for precise point positioning, millimeter level accuracy, and the centimeter level accuracy, this Rtk. Okay, so you are interested in a atmospheric domain, or you are in a atmospheric people. So you may, what we have done, we want to see this survey grade. What we have done, we have simply split the signal with this survey grade antenna. One side we have put that like a receiver, and another side we have put U-blocks MAT receiver. And we want to check the atmospheric monitoring, and you see these CNO values with respect to time, with the low cost receiver and the survey grid receiver. Here you get carrier to noise ratio value, that is dB hertz. You get the fluctuate, it's a below little bit. Okay, because it's a single frequency. And when we put the standard deviation and the survey grade receiver and the compact receiver, you see the data are similarly, it's not matching. So you see standard deviation for CNO in L1 band, and the elevation angle we have considered here the GPS PRN number 28. Here also we have considered GPS satellite PRN number 28. The data we have shown it. And the later what we do the same experiment with these dual frequency U-blocks JDD F9P. And you see there, you see here, when we calculate the VTAG value with respect to time, you see it's similar. Okay, and similarly we have logged the data here for July, and here we have logged the data for September to different month, and we want to validate, is it this receiver give it to us the same nature? Yes, you see the receiver what this geodetic receiver provides, with this low-cost receiver also provide the similar kind of data. Okay, we have calculated it for VTech both the cases. So from this experiment, you would clearly understand that here the size you have reduced. You have reduced the power. As earlier I have mentioned, it's require only 5-volt data or your USB data power, and the cost efficiency, this. Okay. And this using this receiver, you can monitoring your you can monitor atmospheric monitor research you can do. And our lab have published this related to this work. If you are interested, you can see this paper. So now come to the application purpose. What we have done the application. See, first, right now I have told you that you have to log the data using a computer. We have reduced also that that part. Okay, single board computer. All of you may know that Raspberry Pi. Using Raspberry Pi, we have put a power bank. We have integrated with uBlocks data, and similarly, we want to check it for Navic. And here we have put some soil moisturing data for temperature, humidity, PM, and we want to check real time. Either you see here your temperature, humidity, what is, it's completely shown, and we have published in this journal. And similarly with this receiver, Navic module receiver, what our laboratory have developed, with this receiver, Navic compatible receiver, we have logged the data in during Amphan. Okay, everybody may remember that Amphan 2020 disaster monitoring. And see, Navic 1A data, using Navic 1A data, we are monitoring this. Our lab have developed one software. Using that, we are monitoring that from which location this Amphan storm is going. And at that time, see the wind speed. From here, you can do. And we have logged 2 location data. One is Kolkata, another is Bengal. We are monitoring these 2 location data. One colleague from Kolkata, he logged it and he monitoring it. And you see these small kind of application you can do with this small compact receiver. And we have published this in journal. So with time constant, I cannot tell much on it. So I come to Navic. So Navic is our own indigenous GNSS system. So you see, it's cover the India, and from the landmass, for its cover 1,500 kilometers. Okay, for primary service region, and this dotted red, it shows the secondary region. Okay, and right now Navic has 7 satellites, and one satellite, this one G is right now is not working. Currently 6 satellites are working. Okay, so from this figure, you may understand that Navic has 2 types of geometry. Okay, one is GEO, another is GSO. GEO satellites are fixed. GSO is varying. Okay, low varying IPP. Okay, this and what is the advantages? Why this Navic is very much unique for us and for the world GNSS community? See, S-band signal. Till now, none of the GNSS, right now, what I have mentioned, the GNSS services, GPS, GLONASS, Galileo, PEDO, and QGNSS, they all provide L-band data. None of provide S-band data. If you do your work with the S-band data, you have to you have to take a Navic receiver and you do your experiment. Okay, you will Navic provide two types of services. For the civilian, it provides standard positioning services to all the users and restricted services or encrypted services to the authorized user, that is the defense users. They will provide it. Okay, and our laboratory, we have did some simulation. What's the best geometry, when we would get the best accuracy with this, when the Navic all 7 satellites are present with this orbit, this location, we will get the base geometry, and this time we will get the worst geometry. Okay, you may get all this information through this paper. And see, so what's Navigate? Navigate, the advantage, as earlier I have mentioned, the S-band. As the orbit, you can easily understand all the satellites are, you would get high elevation angle. Why high elevation angle? Because when I talked about the multi-GNSS concept, that time I have already mentioned that when you are in an open sky environment, you will easily get 4 number of satellites. When you are in a terrain environment or in a forest canopy or in a congested area, there you may not get 4 number of satellites. So in India, as you know, we are not planned, many cities are not planned, and we have the forest and all those things. So each and everywhere you will get the 4 number of satellite with the benefited of high elevation angle satellites. Okay, and Navic provides you a 5-meter precision. Okay, in single point position. Why Navic is required? See, we have did simulation with GP. If you are taking that GPS, GLONASS, Galileo, you see, in a day, 2 times in a day, you will not get above 60° 4 number of satellites or 1 number of satellites. Any one you cannot get. You see. So in see this GPS is for USA. You see, USA don't have this kind of problem. Galileo is for Europe. You see, they are the European region. They are the no problem. That GLONASS, you see, this Russia, there no this kind of problems are available. But with respect to South India and Eastern and Northeast India, you will get this visibility problems. Okay, what I already mentioned. And the northern India, we have did the simulation as well as the data. From this data, this black line shows above that no visibility problem, okay, arrived in India. Below this, the visibility problem are arrived. And you see this simulation data and this data both are matching. Okay, we have take various location data, and we did this experiment, this simulation, GPS, GLONASS, Galileo, and Navic. With Navic, you see this 1,500 kilometer that area, Navic coverage, that area you see clearly vanish. That problem is not there. So this high elevation angle Navic is required. Okay, for our is I will show you one of the benefits for Navic. You see this paper if you are more interested. So as earlier I have with my discussion, I have mentioned about the compact module, but still I have not mentioned that Navic Tenable compact module. Yes, I have mentioned this NT-lab, and there I have already told this NT-lab is a dual frequency GNSS receiver. See, Navic is L5 plus N, and this is one Indian company with support of NT-lab. They have developed this. This also this receiver also provide Navic L5 plus S signal along with GPS signal. And these few companies are also available in the Indian market. You see, they are provide only Navic L5 band signal. Okay, this Skytrack, this Delete, this QuickTel, and Alistair data. Okay, and these two receiver are very much costly because of this S-band data. Okay. So this cost cutting and the antenna problem when we are starting our work in the day 2016-17, we cannot get the cheapest receiver or low cost receiver. We have not found. Then our lab, with the guidance of Professor Onindo Bose sir, we have tried to develop this Navic receiver. And this is the first generation receiver. And this one, that's why we call this GLB1, GLBN1. And this, when we develop this GLBN2 receiver, you see the size. It's up to 4 centimeter by 7 centimeter. Okay, we have reduced it the size. Okay, and we cannot get that time that compact antenna. Okay, low cost antenna we cannot get. So we think why we can develop the Navic GNSS antenna for our own research purpose, or we can say Atmanirbhar Bharat. So at that time, we have developed these three kind of antennas are there. Okay. And what earlier you have seen that we have did the agriculture monitoring with this U-Blocks receiver. Later after this Navic receivers, we have developed or we can get the Skytrack module. Both of them we have checked it, and we have did the same. And yes, we get. You see here right side. We have connected it through power bank and antenna. This antenna we have connected, and you see the data. All the data are coming. Okay. So from there you can see we are totally Atmanirbhar with this Navic module, and we will check it. This is our Bardhaman University campus. This is our physics department. Inside motorbike, we have put. We have say we have both 2 person. We have seen one is driving the motorbike, and another person just keep all those things in his hand. And we want to take a road survey, and we see this, okay, that even we are in a dynamic condition, we can get the data, hold the location, okay, with this Raspberry Pi module. So If we if we want to do the experiment in dynamic condition, previously what we have to do, you have to put a computer or desktop or laptop. So we have reduced it through single board computer Raspberry Pi. So here huge cost cutting we have reduced, and we get the similar accuracy data what I have already told. Later, what we have done, the water quality monitoring system with this system. Earlier, you see, with this agriculture monitoring, then we go for the water quality monitoring. See what here, what we have done, we have put a solar panel. From the solar panel, we get the power. Okay, previously we have used for through a power bank. But when you take a continuous data or you put your when you measure your water quality, that means you have to put your whole system. It should be an indigenous system. Okay, so for that we have put this solar power, and from the solar power that through power bank it's come, and if you require the display, it's shown all those things. If not, then it's a plug and play. And the control unit, we have monitoring here, and you can log the Navic data. Okay. And what we have put pH sensor, temperature sensor, we have put flow meter, turbidity sensor, and other sensors we have put it. And we have checked few things. Okay, these things we have not completed properly. After we completed, I will definitely inform you all. We faced few problems. So we have rectified those things, and as soon as possible, we want to modify those problems, and the data, and we want to give it to you, the information to all of you. And see, you can give this module to in a river, in a pond. So what we think that, and our lab developed a module, okay, communication module. With this communication module, with the help of internet, it will come to our university. Our lab have one central server. It will come to the central server. Through the central server, you can see the real time all these value, pH, temperature, flow meter, all these value. Okay. So this is the block diagram. So from this, what you will get, you can measure the real time water quality measurement, and you get the which location. Okay, it's location enabled, which location your water quality, that turbidity or these things is very poor. You can measure the water temperature also. Okay, and you will get the real-time information. And as earlier I mentioned, you can send it through a central server. And what we did the whole system. This is for the prototype cost. Prototype we have cost around USD $350. Okay. If because we have to test it lots of lot. After that we can say, okay, this total system is ready. Before that we cannot say. So prototype cost, we have calculated it. The cost is around $350. Okay. And come to end of my presentation, what we have learned from Japan, from France, what I have learned and my professors, we want to give the training and expertise with these low-cost modules. Okay, Here we have trained NATO, Hyderabad. It's one university. We have trained GNSS workshop different SBNIT Surat, the University of Burdwan. Here we have trained MSc Geospatial student and MTech student and other department student. We have trained how to use this survey grade receiver and this low cost receiver. Here my professor is showing. And we have shown the NIT Sikkim, Mizoram, and so on. So like that way, what we know and what my professor think and what our lab think, what we know, we have to share our knowledge to other. With your share knowledge, you can learn lot of things. So we have trained so many people. So in future, I want to see, or our lab want to see, so many experts are available with these small compact GNSS modules. So with this, I would like to thank my philosopher, my guide, from whom I get the guidance, support, motivation, and acknowledgement. My sincere thanks. I cannot say it's my thanks. It's my gratitude to my professor, Dr. Anindo Bose, to whom I have learned so many things, and I want to share it. I would like integrated test range DRDO to carry what I have shown you few data. And today I am present this talk from ITR DRDO lab, Chandipur. They give me the permission to allow me, I can say, from this defense lab, they allow me to this talk. And I would like to thank DST ACRB for sponsoring our agriculture, what I have shown, we have developed. And last, all the members, those who have attendees, I would like to all of them, you may visit our website. Here I am not promoting you. From there, lots of tutorial information are available. If any we get any training information, we came to know, we just put in our lab website. And so I'll request or suggest you please visit our lab website continuously, so that from there you may get few information when we give us the training, or any other agencies give the training. With this, I will like to once again thank you, Director NATMO, Dr. Tapati Bandopadhyay Madam, and all the colleagues of NATMO. They are think that I am capable to do in this such a prestigious platform. So I would like to thank once again. Thank you, Madam. Thank you, the entire team of NATMO. Thank you.
Thank you so much, Mr. Mahato. After this informative speech, we will proceed for an interactive session, which will be initiated by Director NATMO, Dr. Tapati Banerjee.
Thank you, Madhurima. Thank you, Somnath. I believe all power is within you. You can do anything and everything. Of course, this is a quote from Swami Vivekananda, and you have started your deliberation with the quotation of Swami Vivekananda. You are truly, this quotation is truly applicable for a young professional like you, especially in this field. And so this is an extensive and elaborative deliberation from such a young professional like you. And I invite that interaction session, especially Dr. Nag. He is with us today. We are very happy to have Dr. Nag here. So I start this interactive session with Dr. Nag. So sir, please you deliver your comment. We should want to know your comments on this session.
Dr. Nag, please.
Can you hear me now?
Yeah, yes, sir.
Thank you very much for your very interesting presentation regarding the technology, the developing technology regarding the location, to find out the location, which is a very important component for any type of mapping. I was not aware that Burdwan University is doing so much work in this regard, but definitely it's a good contribution, and we would look forward to more research like this and its application in mapping as well. Now, you have used a lot of abbreviations and acronyms, which makes slightly difficult to remember everything. But whatever I could gather is that the accuracy part which you have been mentioning, somewhere you have mentioned that 5 meter accuracy, then you went to sub-meter accuracies. So what is how you are comparing or linking this 5 meter accuracy and then you're going to sub-meter accuracy? This is one question. And second is that I understand that you must have done some experiments on the ground using this technology. So one is the system-based accuracies. And then when you do this testing on the ground, then you get accuracies as well. So do you find any differences that the system says very high accuracy, but on the ground, the accuracies may not be that high? If it's like this, then what are the reasons? These few things we would like to know. Over to you.
Thank you, Dr. Nag. Yes, first, I have mentioned that as per user requirement, suppose, sir, you are happy with 5 meter accuracy, then simply you log the data. Okay, you will get the 5 meter accuracy, sir. And see, for you may know that the DGPS will get you the decimeter level accuracy. So I know that NATMO is doing mapping. For mapping a location, you require high precision data or high accuracy data you need. So
it depends on which scale we are mapping. The accuracies are related to that. For example,
yes, various literature showing that with the confidence level of 95%, we are calculating 2D RMS. Okay, 2D RMS and CEP. Those two are for 2D correction. If you calculate the 3D or you want to take the altitude value, so for that you need you have to take or we have already developed one software for that. So for that you have to calculate ACP, spherical error probability, and mean radian error probability. These are the very standard numerical are already available, sir. With this numerical, we have calculated those and we have developed our own code. We have developed software and we have uploaded the software and we can get the data. Or if you have any processing software, you do this mathematics equation and you can get the accuracy. And another question, sir, your next question is system based. Yes, sir. That's why I have mentioned the advantages of multi-GNSS. Okay, multi-GNSS, when we consider multi-GNSS system, what I have checked that for GPS, Galileo, and GLONASS, if we consider these three, then you will get a better result, sir. Instead of single GPS, instead of single GLONASS, and single Galileo. So I will suggest you want to take this First, high accuracy, for GPS, GLONASS, Galileo, this combination. Then you will get the little bit less. You will get GPS combination. Little bit less, you will get.
Understood. Understood.
Then you will get GLONASS.
More number of satellites, you get better accuracies.
Yes, sir. Yes, sir.
The question is that the system accuracy.
I have that answer is this, sir.
Yeah. Okay. The difference between the field accuracy and the system accuracy. Was there anything ever any experiments being done?
Yes, sir. We have done the what we have get from the location information system, that receiver we have, the GNSS receiver. With that receiver we have done.
Mathematically, the whole system, how much accuracy it should give. This is one thing. You may be using 2 or 3, whatever satellite, and then when you go to the ground, what type of accuracy you are getting? There must be differences.
Or yes, sir.
What are the
yes, you see that when I present the Navic presentation, there that ISRO have already mentioned in India you will get below 10 meter or below 7 meter accuracy. That they provide the standard manual is already available. Like that, GPS also provide the one manual. From that, you will get. They all are saying that without any doing any correction, you will get a meter level accuracy, sir.
Yeah, but first-hand information, if I could get from you, that
yes, sir.
How you are getting, how much accuracy you are getting in the field, perhaps it would have been better for us. Anyway, the other major change in the country is the CORS being established all over the country.
Yes, course network, sir.
Continuously operating reference.
Reference station, sir.
Yeah. So they are also giving accuracies, and with the drone and the CORS combination is almost coming in competition with the GNSS and remote sensing. People
Yes.
may prefer CORS and the drone data to
Yes,
get
sir.
highest accuracy, to the extent that the mapping at 1:500 scale is also being conducted all over the country.
Yes, Survey of India is doing that, sir. Project.
Yeah. So how do you compare this scenario with your GNSS and remote sensing data? And then
No, that is the, sir, total difference, sir. That is the network based you want to get the data.
Whatever it is, we are ultimately, we understand the accuracies for the
Yes,
preparation of map.
Yes, sir. See, when you are see, from your question, sir, it is easily understandable that if you have getting the correction from multiple servers or course network, you are getting the data uploaded in a central server and you do some correction, you will get what the Japan has done. Using this course network, sir, they have predicted 15 days before the earthquake monitoring, sir, and they have patented it. And so what we are doing, sir, we are in a small university and one location data we want to send a server and we did the correction and we get. So it's if the course network is developed, it's established in all over the country. And if we get the permission to access that server, and with this, as with my presentation, you can easily understand this small receiver can give it to you the accuracy. And this receiver also, if when the course network is already stable, if I go any location with this small module and with the help of course network, I will definitely say, sir, I will get more and more accuracy. Still what I have done, because this thing is not, I am not associated with that project, or I have less information, so I cannot comment on it.
Consider that your GNSS based whole system, if it is integrated with course-based system, and then you
Ye-
can get better and better accuracy. So one
Yes,
day
sir.
you may have to consider that.
Yes, sir. Definitely, we will consider it, sir.
There are many questions, but there may be other participants. So
Okay, sir. If you have any question, you please send me an email, sir. I will happy to answer it, sir.
okay, thank you.
Thanks.
Somnath, what Sir is telling that as the coursework is network is going on at all over India, pan-India level. So I think it would be better if you work with them. If you have a chance to work with them, I think accuracy will be more in your case. So
Yes,
try for
madam.
that
Yes.
one to
Yes, madam.
contact with them.
If I get the opportunity, I will definitely work with them.
See, this whole course data will be available without any difficulty. This is what the Department of Science and Technology is projecting. And it is, you have to take some, write a letter and get the data. So should not be problem.
Whom we have to write a letter, sir? Okay.
Yeah, with new guidelines, these things are being made accessible to everybody.
To whom we have to write the letter, sir?
Survey Journal of India, Survey Journal of India.
Okay, sir. Okay. So I will later I will communicate it with you, sir, regarding this matter, sir.
Okay, sure.
Okay. Thank you, sir. Thank you for the information.
Thank you.
Anybody else who want to ask Mr. Mahato, please come forward.
Can I ask a question? Can I ask a question? Can you hear me? Madhurima?
Yes. Yes, madam.
Yes. Thank you very much. Good evening, everybody, and good evening, Professor Nag. And it's so nice to see, and of course, Dr. Tapti Banerjee and all of you to be here. And that too amidst learning. I thought that we've come here to learn about GNSS, but you also told us about course. So one will go and further do that. As always, you're giving an extra edge to the lecture. Somnath, I would come to you. It is wonderful. What I liked about you were three things, especially on the Youth Day, what I gathered in the poster. That was actually the reason why I thought that I'll join. The moment I saw youth, and I thought I'm linked in, teaching them. And of course, Navic and GNSS and all these, of course, interest me. You were very good. You were very good in explaining. And you told us all that. I have, of course, I'm not going to go in a technical framework and asking you questions. My 3 pointed questions are small questions. Just tell me, you were too magnanimous for being such young in giving, say thank you and gratitude to even, Dr. Tomoji, if I'm not mistaken, and your Dr. Bose, your teacher, and also, the way Vivekananda said that we should share information. So I'm taking on from there. You have a lot of knowledge and you're working in that scenario of, and you're open to teach others also in a very flexible way. And you want to extend your hand to that. My question to you is, what are the basic qualifications that a youth of today should have to think of learning about GNSS or Navic or any GPS system or GLONASS or anything, in case if they want to go deeper into you. If they say, my question is, if they want to become SOMNATH, if you, young generation wants to become SOMNATH, then what are the basic qualifications? Can people other than students, other than physics department or a computer science department get into that learning stream or not? And for that, what are the basic things that they should add on to their learning, to understand the complexity of it, or they will only become user? That's my question one, the basic qualification. Number two, my question is that, you said that, you're also open to have workshops and to teach and to do that. So what are the streams that you're looking for, conducting these workshops? Say, I teach geography and, I teach remote sensing GIS, and I also teach in a place where we have students from computer science, students from physics, very high-ended place where, our last deadline of entrance level, but the graduation level students, and we have, this year also we had students with 12th class cutoff of say 99% and 100%. We had more than 100 students with 100% marks. So my question to you is that which are the qualifications that you're looking to engage with in case if we really want, and of course network is also expanding and we want to expand user base. And in case if we want to engage students in learning about GNSS or learning about the relevance of accurate location, then what cost can they buy and say there's a my third question is that a small question in case if an institute an academic institute wants to set up a lab the way you have, the way Burdwan University has set up a lab, what are the basic things, how much cost is required if somebody wants to set up a lab like yours? And that's, yeah, let's just do that because it go on and on. This is not my show, it's your day. But of course, before parting from here, I want to say thank you. You're very good. We are so proud to have young people like you in our country, the ones who are humble and are taking the journey of this important important aspect, which is so very important in making maps or anything that we want to do in GI science environment or geo ecosystem. To you, Somnath.
Yes, madam. Thank you, madam, for your question. I will come one by one with the answers. Okay. First, I will say age. No matter how age is there, I know one of our elder sister is doing his PhD in our lab. With he has a very small child. Okay, he often came our lab. What is age? Maybe 6 or 7. We are doing the satellite and all those things. Suddenly, we will see he draw some satellites. Okay, image, and come to us. Bhaiya, see, I have drawing these things. So for that day, I believe that here no age is there, madam. What you need a dedication and patience. And for yes, of course, you do research for that. Yes, our lab provide the internship for the bachelor degree students, master degree students. Okay, and the qualification I have put and the students. Yes, madam, I have my background is for electronics and communication engineering. Right now, I am doing for this mapping. I am doing for the geography student, for the geospatial student. For I am also working with that physics student, and here lots of application are there. See that power grid. The power grid, there the timing, accurate timing is required. The ATM machines, their exact timing is required. So that the not only physics there, it came the electrical engineers come. Okay, madam. And the as earlier and as Professor Nag already with him question, I have mentioned about the equations. So from that equation, you see the mathematical peoples also come. So it's a very huge, madam. And why physics? Those who, as earlier I mentioned, those who are from the atmospheric background, madam, they can also join. Each and everybody can contribute their knowledge in this domain. They may not know all the technical knowledge, but they are doing if they are doing with the help of this, it can contribute our society to get betterment. See, right now, madam, you may aware that our new transport policy, there you can get the alarm systems. So those who are mechanical background, they have developed the car and all those things. they are the alarm system that through that navigation system, you get the information to the local police or it go to the central server. Like that way, Indian government are doing the bill, they will pass a bill or maybe pass. I have read an article. So like these people came and contribute their expertise and what they can do in this domain. This is my first answer. The first as well as first answer. And the workshop. When we are doing our university, doing such kind of workshop, we have opened for all the system, madam. Arts, commerce, engineering, science, each and every department we have opened it. So many of the students, they maybe give it to us a good idea. So why we can miss those kind of idea? Because I'm not from that department or that, but I don't have that much of expertise. With the expertise of their help, we can do something new. Okay. And the cost of lab, madam, with my as much as you can expend, as much money. This is my first. And my, if you see my first slide number 5, there I mentioned that if you have the Android mobile phone, what does it mean? You have cost is 0, madam. If you have the app, you can get the data. You can work with that. So with my presentation, today with this National Youth Day, I give it to you, developed a lab with a 0 cost, madam. And thank you, madam, for
No, just a small, I'll get in touch with you. We'll design a workshop for geographers via you, through you, and we'll work it out. Thank you very much. And God bless.
Send
God
an
bless.
email to my professor. You will.
I'll do it. I'll do it. Okay, thank you.
You will let me know.
Let me add here that Department of Science and Technology, through the National Geospatial Program, has taken up this part, the geodesy part, and this thing very seriously, to the extent that a center of geodesy has been established in the Indian Institute of Technology in Kanpur. So we are supporting this type of activity through our geospatial program in DST. So if there is any activity you require, any funding required, you can go through the procedure.
Yes, sir. Definitely, sir. We will keep in touch with you, sir.
Okay.
It was a wonderful interactive session for us. Before we wind up, I want to thank all the participants, officers and staff members of NATMO, Director NATMO, Dr. Tpp Banerjee, and of course, today's guest speaker, Mr. SOMNATH MAHATO. Thank you all again.
Thank you, madam. Thank you.